So this discussion is about vehicle simulation and styling. What we've been hearing from our customers is that there's a huge demand for us to be able to help them make more aerodynamic vehicles. And this becomes even more critical with the electrification of vehicles and making sure that we get the most mileage out of any kind of charge, or even with gas engines. And so this becomes more of a focus, not only for the build of the car, but especially in the design of the car. Being able to design a car that's both beautiful and aerodynamic is something that our transportation and mobility partners have asked us to try and tackle with our solutions. Next slide, please. So in order for us to describe what the solution is, sometimes it's easier for us to start describing what the issue is that we're trying to overcome and what our solution isn't. A platform is often described as a lot of things, but in this particular solution, we're going to see how we can use the platform to overcome the main issues that really challenge and slow down this process, or keep aerodynamics out of the design studio as part of the data they can consider. So what we're looking at is a general map of how aerodynamics might be included in studio right now. The two red bars are barriers that we often come up against in order to be able to do that simulation. One is often the connection between the aerodynamics team and the studio itself. Usually there are significant delays between the studio's initial concept design and being able to get the results back from the CAE team. The other bar represents visualization. Sometimes it might take, a week in order to be able to then get the data into a visualized process where designers can really understand and utilize that. Normally, the passover is very discrete. It only happens a certain number of times, sometimes not when design really needs it. So now let's take a look at Dassault's process.